Thank you so much. The idea of this presentation is to talk a little about the thing that we talk already for at least 7, 8, 9 years, indoor navigation, indoor location, indoor positioning, and so on, how cool that is, how every hospital needs it, how you're really going to be able to get to the gate and more than get to the gate at the airport or find the mall and find the store and find the shelf and find those cookies. And for whatever reason, right, you don't really see this happening so much. So first of all, there are different technologies that are being used from ultra-wideband to RFIDs, BLEs, and of course Wi-Fi. Wi-Fi always comes to our mind as, oh, we'll use Wi-Fi because it has this great advantage that we have billions of devices, billions of clients that can actually do these things. We already have infrastructure deployed and so on, compared to maybe earlier when we had presentations for some other technologies which may be expensive and they don't have client availability. There are several generations already of this Wi-Fi or indoor location positioning. First early ones were based on the Wi-Fi beacon RSSIs, and that was horrible. That was like 30, 40, 50 feet off. Then the second generation, 2016, 2017, 11MC with, claimed accuracy of 1 to 2 meters. By the way, we were never, ever able to achieve really those numbers. Those were just claimed numbers, and I'll show you later there's really not much research. And then 11AZ, promising much higher scalability, much better accuracy, below 1 meter, 1 feet, and so on. And there's a new standard already in the works, 11BK, which talks about centimeter accuracy. Now let's see what are the use cases. You will hear all the time about these use cases about asset tracking, where are the packages, or geofencing. Oh, if that patient wanders into the wrong department in the hospital. Or this picture is actually from the real application that UC Santa Cruz is using for blinds, to guide the blinds through the university. So there are some real implementations. Locating devices, personal delivery in the restaurant to your table, on the beach, to your whatever you are enjoying then. Is that real? Well, I don't know. We'll talk about that. What about peer-to-peer location tracking and navigation? Again, access control, yeah, hopefully not. Device finding, docking assistance, which luckily they use different technologies, home automations. We hear about these things all the time. What's the problem? Again, the problem is the accuracy and the clients. We do have Wi-Fi clients. They claim 11MC support, but it simply doesn't work. There's no other way to put it. It simply doesn't work. It is way off. It loses the location. It has hard times finding the locations and so on. And some of this is also based on your infrastructure, right? So double bandwidth reduces the errors. Well, if we are using 20 or even 40 megahertz channels, which are still recommended and so on, then accuracy is off. One antenna versus multiple antennas, yes, but we are talking about client, we are talking about dependency on the battery power and so on. So it may not be feasible to use 3 or 4 antennas at the same time to improve the accuracy. And it is simply the quality of the clients and the receiver sensitivity. So multiple reasons that I can think of why this doesn't take off. And let's see what may real life tells us. I was trying to find any proof about this 1 meter, 2 meter, sub-meter, whatever, accuracy, and so on. There are only 2 campaigns that I could find. One was at Wi-Fi Alliance in Santa Clara lab, and this is what they published. They were their results. The other one was, I think, by Volvo or some whatever car manufacturer, I forgot, that they were testing this access control using the Wi-Fi, opening your car, starting your car, and of course, they failed. You don't want to use Wi-Fi at this moment yet to actually unlock your car and to start your car. It is not secure. It is too easy to spoof. It is too easy to simply replicate the signal and steal your car, because your car key is probably in the bowl at your front door. So AZ is promising some improvements. Accuracy at 160 megahertz will be sub 1 meter. Yeah, we have to start using 160 megahertz channels. Security, they did actually introduce physical layer security based on secure long training field. Scalability, they are also promising better scalability. That's important, right? When you really do this indoor locationing and wayfinding and so on, we are talking malls, maybe hundreds, thousands of devices. We are talking sports venues, thousands of clients that are trying to get the location and communicate, right? So scalability is ultra important. 11MC doesn't have it. So AZ is promising that. Then also the privacy. Who gets the report? Just the client and the access point, because it's important, right? If the client is the scanner, not only that the scanner needs to know where it is, it's also good that access point knows and reports that to some maybe central location where the network management system can take advantage of this. And then it's also idea of so-called passive location in 11AZ. That means that client just listens, just like your GPS, right? Like your phone, it just listens. Your phone is not asking, where am I, right? It's just listening to GPS to tell you, you are there. So 11AZ is kind of going into this same concept of passive listening. Just tell me where I am. We have yet to see how that really works. This is still a lot of theory. So what are the real life use cases? The most important and the real use case that we can already show you today is for AFC indoor, so 6 gigahertz AFC indoor standard power, where access points need to know the geolocation, the GPS coordinates to communicate to the AFC servers. So that's the real use that we see today. Without this, using 11MC and this ranging technologies and so on, admin would have to kind of manually set the geolocation for every access point. So how it usually works. The common implementations are that you have to simply choose some called anchor or simple access points, maybe 3 to 4 per floor, where you set where the geolocation is determined, not set, determined. And then basically using the ranging technology, all the other access points that have no GPS access can configure also these geo-coordinates. The popular way of doing is using the mobile app. We trust the GPS on the phone, and using the phone being in close proximity to the access point, mobile app can tell the GPS coordinates based on the distance from the access point. Access point now learns GPS coordinates. Access point knows the neighboring access points, knows the distance based on the ranging technology from the neighbors, and that's how basically all the access points on the floor can learn the geolocation. It can be 3 or 4. It can be for 2D, maybe in future for 3D. 3D means that we can know for the entire building. And this also helps in the future for auto-positioning access points on the floor. Access points move around, right, magically. Every time you have some painting or whatever jobs, access points magically move. So with this technology, we can now actually tell where they are and find them. And hopefully this will help the client location to have better accuracy and the client vendors to jump on this. So I know I'm going over, but we do have actually a demo if this works. Of course, it's not going to work. No time. Ran out of... Huh? I'm over. Okay, sorry. Basically, what I wanted to show was, was that we did all this in our lab. Access points learned their geolocations, and the client, as we walked, we were able to see how accurate it was. It was accurate within the small, maybe couple of feet error. Sorry, thank you.